So when we're giving coordinates like this, it's always a good idea to be able to sketch a picture. Okay, so I'm just going to sketch a quick diagram here. 2, 7, maybe somewhere around here, and 5, 28, maybe somewhere around here. Okay, it's going to go up like that. Okay, so I know that slope's probably going to be positive, and I really want to have my rise and run. So I'm going to draw my slope triangle here. Okay, so my change in y. If I want to find out the change in y is going to be, and I'm going to say that I'm going in this direction, A to B. Not that it really matters, but I'm just going to do, as long as I'm consistent, I'm going to say that the 28 is my end position, minus the starting position gives me my displacement. It went up 21. Okay, and then for the change in x, it's going to end at 5. It started at 2, so we went across plus 3. So then the slope ratio so my slope is going to be equal to my rise over run ratio. So it's going to be plus 21 over plus 3. Okay, we can leave it like that, or we can simplify it to its unit ratio, and the slope unit ratio is going to be 7 to 1. And again, always remember that there's a one number slope. The other number that's implied is going to be 1, because slope is two parts, rise and run. So when I have a slope like this, I want to draw in my triangle. Okay, and I can draw my triangle from anywhere really. So I can do it between these 2 points. I could do it between these 2 points here. I'm going to do a bigger triangle here. Okay, like that. And then work out my change in x. It's going to be, I'm going to end at 3. I'm going to start at 1. So I've got a plus 2 run. Okay, kind of went in that direction. And my rise is going to be my change in y. So I'm going to end off at 350. I started at 250. So then I gained $100. Okay, so that's going to be my rise. So my rise and run ratio, my change in y over change in x. So my change in y works out to be, I went up $100. Okay, and the run was, I gained 2 months. So that's my ratio. That's my slope. $100 every 2 months. Now, we could probably simplify this into a unit ratio. If I divide, I get my unit ratio, and I get $50 per 1 month. So every month. Okay, and that is the rate of the problem. So this is a rate at which we're growing money. We're growing money at $50 per month. Okay, and this is a rate. The slope is the same as my rate in this particular problem. Okay, so when we talk about slope, we have physical slope, right? So it's like a hill or a roof, but we can also think of slope as a rate. Okay, how much something changes vertically, okay, compared to how much things change horizontally. And we can find the changes by doing subtracting. Subtracting the coordinates gives us the changes. So taking a look at this table of values, we can see that we start off, I'm going to just sketch a quick diagram here. I've got 0, 5, 10, 15. Okay, I start off at $30. I go all the way up to, let's say that's going to be 100. Okay, let's say that's going to be about 180 up here. Okay, so at $30 we start, $5 we're at about 80, $15 we're going to be at about 180, and we get a graph that kind of looks like this. Now, where do I see slope in my graph? Well, I see slope in my graph as my rise, okay, the change in y. In this case, I've gone from 30 to 180, or so from 80 to 180, so I've gained $100. The change in x, my run, I went from 5 to 15, so I went 10 x is computers. So the cost of shipping computers is going to cost $100 for 10 computers shipped. Okay, so there's my graph. I can determine the slope. Okay, so I'm going to work on my slope here. So my slope is going to be equal to the change in y over the change in x. Okay, so it's going to be the change in y, which is plus $100, compared to my change in x, which is I've gained 10 computers. So computers. Okay, so this is my slope. It's going to be $100 for every 10 computers. Maybe we'll do a unit rate or unit slope. It's going to be $10 per computer. Okay. What's the ratio of changes in y values to x values? Well, the change in y on the table I could show like this on the outside. So the change in y is equal to $100. So change in y is going to be $100, and the change in x is going to be plus 10 computers. And we can see we can kind of pretty much see that ratio of change on the table here on the outside really is my change in y and change in x. So this ratio on the outside represents my slope ratio. The unit rate I've already done, it's $10 per computer. Okay, and again, make sure that we have the unit. If we keep track of the units, it makes it much easier to interpret. So where else does this ratio show up in the relation? It shows up in the triangle, okay, our slope triangle. And also as a rate in this problem. Okay, so as a rate in the problem. What's the relationship as an equation? It's going to look like this. The cost, so the total cost is going to be equal to, well, where did it start? Okay, so those are two things we look for. We look for the starting value, and we look for the angle or the change, okay, or how it changes. Okay, so the angle, the starting value is going to be, we start at $30 charge, maybe it's a surcharge or something like that, and then we're going to add on $100 for every 10 computers, or we can just do this as $10 per computer times the number of computers. So this starting value shows up as a constant. The slope or the rate shows up as a multiplier. Okay, there's my multiplier. And when I write it out in XY form, it's y equals 30 plus 10x. Okay, where x is the number of computers, y is the cost, and again, that constant value relates to the starting point, and this multiplier relates to the slope. Okay, being a one number slope really is, although the slope is 10, really is a rise of 10 compared to a run of 1.